Today's topic is integration. Integration for physics. If we talk about maths, then integration is a very vast topic. Very, very vast. But for physics, we have to use a very minute amount of integration. Now let's recall what do we mean by integration. Okay, then integration we cannot understand without differentiation. Like we have two things like multiplication and division. Okay, so multiplication and division is synonymous to differentiation and multiplication is synonymous to integration. Okay, division is like y by x, so multiplication is like y into x. These are the simpler terms, but if the variables are changing very rapidly, then their division is called differentiation, and if the variables are changing very fast, then their multiplication is called integration. It is called integration. Okay, now what is the fundamental use of integration that you will learn in maths? In physics, the first thing that you have to remember is the formula of integration of x to the power n. Here dx shows what is the variable that is to be integrated. Okay, now the formula for x to the power n, the integration of x to the power n is x to the power n plus 1 upon n plus 1. The power is increased by 1 and the same factor is in the denominator. Okay, so let's see by two examples. If we have to integrate x cube, then its integration will be x4 by 4. Okay, x to the power 3 plus 1 upon 3 plus 1, which will result in x to the power 4 upon 4. One more example. Suppose we have to integrate 1 upon x square. So I have to bring x square in the numerator. So the power is increased by 1. So it is minus 1 upon. Okay, the integration of 1 upon x square is minus 1 upon x. Let's solve one more example. Let's say we have to integrate 1 upon root x. So we can write root x as x to the power half. Now x to the power half, when it will come in the numerator, it will become minus half. And then x to the power minus half plus 1 upon minus half plus 1. It will become x to the power half upon half. It will become 2 root x. This is the fundamental formula of integration that is required in physics. Now one more aspect of integration, like division and multiplication. Division and multiplication are reciprocal of each other. They are the reciprocal of each other. Similarly, differentiation and integration, they are reciprocal of each other. Reciprocal is not the right word, but okay, we can make do with this term. What is the meaning of this? The meaning is this, that if we integrate and differentiate a function, then they will cancel out. This integration will cancel out differentiation. Similarly, if I write d by dx, integration of y dx, it will also become y, because the differentiation and integration will cancel out each other. You can see it by an example. Let's say y is equal to x to the power 4. First, I will differentiate it. X to the power n, the differentiation of x to the power n is, take power outside and reduce the power of x by 1. So differentiation of x to the power 4 will be 4 into x to the power 4 minus 1, that is 4 into x cube. Now integrate this formula. If I integrate the formula, if I integrate this function, then constant when multiplied with the function always comes out. Okay, now integration of x cube is x to the power 3 plus 1 upon 3 plus 1. It will cancel out and we are left with x to the power 4, the same function that we started with. So this example proves that integration and differentiation both are reciprocal. Suppose y equals to x square minus 5. If I differentiate it, then I will get 2x. And if I integrate 2x, I will get x square. Now, I just said that differentiation and integration are reciprocal of each other. I differentiated this function, it got me the answer 2x. And then I integrated this function and I got x square. What about this 5? Now, I did not get this 5 in my answer. So, here is the loophole that if we differentiate a constant, then the differentiation of a constant is 0. So, we are not able to retrieve it we have two methods. Either we have to write a constant with plus sign, okay, and the other second method is of limits. We'll talk about limits later. First of all, let's talk about this constant. Why is this constant needed? Because of this case. Okay, here in this case we have clearly seen that the integration, when we differentiated 5, we got 0, but the 0 we were not able to integrate it. So if I simply say that differentiation and integration are opposite to each other, then after every integration I have to write a constant plus c. Okay, without it the answer will not be complete. So in every integration, whatever the integration, we have to write always have to write a constant with plus sign in the end, whatever be the case of integration. Third, the second method is of limit. Okay, the first method is of adding the constant, second method is of limits. So how limits are added? Suppose we have to integrate x square. So limits are written like this: 1, 2, 3. How to deal with the limits? First, integrate it in the normal way. So integration of x square is x cube upon 3. Now we have to put the limits in it also. So first, this is called upper limit, this is called lower limit. So how to solve? First we put the value of upper limit in the answer. So I will put 3 instead of x. Then a sign of minus will come, and then I'll put the value of lower limit instead of x. I will get the answer as 27 upon 3 minus 1 by 3. Answer is 9 minus 1 by 3, and it is 26 upon 3. Let's see two examples. One more example for the limits. Suppose this was our question, 1 upon x square, and the limit was minus 2 to 4. So how we will solve it? I just showed that the integration of let's solve it one more time. So minus 1 by x is our answer. Now I will have to put the limits also. First what are the limits? Let me write it like this: minus 2 to 4. First of all, I will put 4 instead of x in the function. Look at this. Then I'll put a minus sign, and then I will put minus 2 instead of x. This is the way to solve limits. So minus 1 by 4. Here the minus will cancel out, and we are left with minus 1 by 2. So we can take the LCM, and this will be the final answer. Okay, so the limits help. Now I just wrote that the integration of x to the power n is x to the power n plus 1 upon n plus 1. But for making this answer valid, the denominator should never be equal to 0. That is, n should not be equal to minus 1. If n is equal to minus 1, then this formula is not valid. For n equals to minus 1, this formula is not valid. So we directly remember the formula. N, that is, function is this, that is 1 upon x. So its integration, we directly remember it. It is log x. And the base of log will be e. Okay, whenever the integration of 1 by x comes, then we will not use this formula because it will give us an imaginary or non-real, unreal answer. So we use this formula, 1 upon x. So if we have to integrate 3 upon x. So how we'll do that? Take 3 outside, we are left with 1 by x integration, and then the integration of log x will become 1 by x. What are the formulas? Integration of sin x, integration of cos x, okay, integration of a to the power x. The integration of sin x is minus cos x. Integration of cos x is plus sin x. Integration of a to the power x is a to the power x upon log of a to the base e. Okay, there are 2-3 more formulas, but those are not used as much in physics, like the integration of secant square x. Now the differentiation of tan x is secant square x, so the integration of secant square x is tan x. Okay, similarly the integration of sec x tan x will be, so its integration will be secant x. Why? Because differentiation of secant x is secant x into tan x, so the integration of secant x into tan x will be. One more example for limits. Example, we have 2 upon root x minus 3 sin x plus 4 x to the power 6. We have to integrate it. Then what we will do, these functions which have plus and minus sign, they are separated as it is, like we used to do in differentiation. Okay, now take 2 outside, it is 1 upon root x, that is 1 upon x to the power half. Take this 3 outside, take this 4 outside. Whenever a constant is multiplied to a variable, the constant comes outside. Now 1 upon x to the power half, it will become x to the power minus half, and on integration we'll get x to the power minus half plus 1 upon minus half plus 1. Here the integration of sin x is minus of cos x, and integration of x to the power 6 is power 7 plus 7. Let's add a constant term to the answer. So we are left with, it is half, it will become 4 into x to the power half plus 3 cos x plus 4 x to the power 7 upon 7 plus 3. This is the final answer.